This is Jack Jackson. We're going to be looking at the ASA triangle congruence theorem and the ASA condition today. So this is part of my sketch, Triangles Ultimate Geometry Sketchpad sketch. Hopefully you can get access to the sketch. You can get in there and experiment with these things on your own. So notice, let me just review that we were talking about congruent triangles. And remember that two triangles are congruent, such as these two here, when basically all the measurements match up exactly. So we have a pair of sides are congruent, the other pair of corresponding sides are congruent here, and the third pair of corresponding sides are congruent, and likewise all the corresponding angles, like this one and so forth, are congruent as well. So all of these measurements that match up must be the same. So you have to have all six of those things for the triangles to be congruent. But the question that's been occupying our discussion and investigation is, what if we have just three of these pairs of measurements congruent? Is that enough to make the other three pairs congruent as well? And so that's going to be our investigation. In the last section we talked about side angle side and side side side. In this section here we're going to investigate angle side angle, angle angle side, angle angle angle, and side side angle. This particular one is going to be working on angle side angle, and there'll be two or three little short videos here on each one of these. So here we're specifying a side length, which is given by this C. Angle A will be specified by this slider here, and this angle slider here will specify angle B. So if we're going to make this construction, it's actually pretty straightforward, and it's fairly easy to do with your compass as well and straight edge. So you figure out how long this is and make a length of that size. If you're just copying this, you can copy it with a compass. You can make a mark here and pick anywhere on that circle. If you're doing it with a ruler, you could measure that and make the measurement the same here. So make sure that that is the same length. Okay, so once we have that fixed and we want to make an angle A, we just take one end and make the angle A. So we know that we started, once we just had once we were just at this point and we have this line segment, we have one of the sides and two of the vertices. We just have to find the third vertex. So we know it's also on that angle there because that angle matches this angle right here. And then the other angle has to be at the other side, and so we'll put the angle at B that matches this one here. And of course the third vertex has to be on both of those rays, both the red and the blue ray you see here. And if you look, of course, there's only that one place that it could possibly be. And we see that there's only one possible triangle here. We really didn't have a choice once we fixed this up. Now we could have put this angle at this end and this angle on this end, but it would just been a mirror image of this, and it would have still been a congruent triangle. So what's our conclusion? Actually, we'll get to that in a second. So we have conclusion is that we get one single triangle here. Now the next question is there any way we can sort of mess this up in the sense that we can come up with some measurements here? Can I adjust this to where there's no triangle that's possible? And the answer is yes, we can do that, but what you have to do is notice if these angles are both too big, then these rays point away from each other and they never touch. And so how big do they have to be? Well, if they add up to 180 degrees, then the two lines are parallel. If they add up to more than that, then they point apart. But if they add up to less than 180 degrees, then they will point toward each other, and they will eventually cross at some point. So, of course, we know the three angles must add up to 180 degrees or pi radians, and certainly if the two of them add up to 180 degrees or pi radians, then there's not enough room for the third angle. So we know that's not going to work. And so really that's the only way we can mess this up. So the conclusion is we do not get a triangle at all if the two angle measurements is already 180 degrees or more. But if the sum is less than pi, that is 180 degrees, then you do get exactly one triangle. And then so then we have the angle side angle congruence theorem, and it says this. First of all, if we're given the actual measurements of two angles and the measure of a side between them, then they're supposed to be from a triangle, then either zero triangles exist. In other words, you can't make a triangle when the sum of the two angles is greater than or equal to pi, that is 180 degrees. On the other hand, if the two angles sum up to less than, not less than or equal to, but less than, strictly less than pi, then exactly one triangle exists, up to congruence. So in other words, you may have, it may be in a different location, you may have to slide it over, you may have to flip it and rotate it, but you could match them up exactly. If we actually have two triangles, then, and we're given a correspondence between the two triangles, such that two pair of corresponding angles are congruent, and the pair of corresponding sides between these angles, that's the included side, that's the ASA condition, then the two triangles have to be congruent. And so that's our conclusion. Okay, so we're going to come back to this in another video in just a minute, where we're going to experiment with working with actually putting in some actual numbers, and we'll get some for you can kind of test out on your own.